G'day again. So, back for some more Year 10 revision in June. We're going to look at the second part, circles. So, if you get a question like this and it says, what is theta? And you've got a 10 out there, what's the rule? So over here, I'm going to write a rule, if you remember. So the rule is, if I've got any 2 points on a circle and I go to the middle of the circle and I join a line anywhere to any point around here, this angle is always double this angle. So we'll just draw a few lines out here to give you the idea. If I draw a dot there, let's draw some dots around the circle. There's a dot, there's a dot, there's another dot, there's a dot, and there's a dot down there. And if we draw any 2 points from there to any of these dots, let's make that, I don't know, 40. So if that's 40, that's 20. Let's go to another dot over here. So there's our dot. We're going over there to that dot. And guess what? That's 40. So this one in here, that's 20. There's another dot. So this one happens to be right on that line. So if we go, well, it is now because I'll make it on that line. And we go to that dot. Well, guess what? It's on the circumference and it will be 20 as well. And so will that dot and that dot. So if we join another one over here, from that dot there, from A, over to there, back to B, like that, and guess what? That will be 20. And if we go to that last dot, guess what? It's going to be 20 as well. So this rule means anywhere you go around here, this is half of this. So if you get a question like this and it says, what is theta, and give a reason, all you have to say is theta equals double that. So theta equals 20 degrees because it's double the 10. And what's our reason? Well, our reason is, and you can say it either way, you can say the angle at the centre is double the angle at the circumference, or the angle at the circumference is half the angle at the centre. So we'll just say it one way, angle at centre is double angle or twice angle at circumference. Okay, so that's your reason. When you put reasons, always do a bracket. It's nice for the examiner to go, this is your working, this is my reasons. It's quite easy to see. And you're done. G'day again. So back for some more circle rules. So this is the second one. So let's say you get this question. It says, what is theta? It's a four-sided shape. It's in a circle, and those two are opposite. What's the rule? Well, the rule's pretty easy. Writing the rule's a bit trickier, but the rule's actually quite simple. What the rule says is, if I've got an angle here, so let's make up two angles. So we'll call that 80 degrees. Then this angle, the opposite angle, the one that's opposite it, must be 100. So these two angles must add up to 180 degrees. Right? They must add up. So these ones, if I make up another angle, these two angles must add up to 180 degrees because it's four-sided and it's in a circle. So if we make up an angle there, let's say that's, I don't know, 70 degrees. Well, this plus this must be 180, so 70 plus 110. Okay, so those two must add up to 180 degrees, and that's the rule. The word you use for that is a little bit longer than the rule from before. So the word you use for this is a cyclic quadrilateral. So cyclic quadrilateral. Quadrilateral. There you go. Bit of a longer word to use for the definition. So here, if it says, what's theta? Give a reason. So you would just write theta equals 70 degrees. And what's our reason? And the reason is opposite angles. So opposite angles is in a cyclic quadrilateral. I know it's a long word. Quadrilateral. Add to 180 degrees. and put a bracket around that. And that's your reason. A bit longer, but you're done. G'day again. So back for one more on circles. And this time you're going to use a rule which isn't actually in the circle, it's actually based on triangles. Anytime you get a question like this, the first thing you should do is notice that those two are the radiuses. And I would write a little r there and there to tell you that that's the same, or put a dash. It should send you back to this rule which you know on isosceles triangles to say this side equals this side, therefore this angle must equal this angle. The base angles are equal, and that's what you're going to do here. What is theta? Well, if that's 120, these two angles must be the same. So you would instantly go theta equals, that's 120, take it away from 180, we get 60. So this would be 30 each. So theta would equal 30 degrees. And you wouldn't have to go through too much of a reasoning other than to say isosceles triangle. And you can use a symbol, isosceles triangle, since both sides are radiuses, or radii, base angles in isosceles are equal. And base angles in isosceles triangle, this triangle, are equal. And you're done.